And it says, what is the inverse of each of the functions below? Write your answers using function notation. So the inverse is what would undo it. So there's two ways to do it. You can either just turn this into a y. I'll do that over here. You can turn it into a y, and then you can swap the x and y, like make them change places, and then just solve it, like get the y by itself again, like this. That's my favorite way of doing it. But there's another way to do it. There's kind of a more common sense way of doing it, and that's what they introduced in your book when they were talking about like wrapping a present and unwrapping it. You can list what happened to x. Like I see that they started with an x, and then they cubed it, and I'll just write it right here. They cubed it, and then after they cubed it, they added 6, and then they multiplied by 3. So if I did want to just, let me do autofocus here. If I did want to just, you know, go backwards by the steps, I would start at the bottom and work my way up. I would undo the multiplying by 3, which means I'd have to divide by 3. So I would grab an x and divide it by 3, because I'm going up. Like if it started like this, first cubed, then add 6, then multiply by 3, then I have to, it's kind of like put the present in the box, then I wrap it, and then I put the bow on. Well, when you undo that, you don't go up here and take it out of the box before you unwrap it and take the bow off. You have to start at the bottom. You have to take the bow off first, and then you have to unwrap it, and then you have to take it out. So you're going to undo starting from the bottom. So that's why I'm saying the opposite of multiplying is dividing by. So I divide by 3. And then the opposite of adding 6 would be subtracting 6. So I'm going to subtract 6. And then the opposite of cubing would be cube rooting. So then I'm going to cube root it. So that's my inverse right there. That's P inverse of X. I'm going to show you how it's done over here too. All I did is I just wrote it down, and I used Y instead of P of X, and then I'm going to swap my X and my Y. I just let them change places, because we know on inverses, we've seen on graphs and tables that the X and Y are just reversed. So then I'm just going to do algebra to try to get the Y by itself. So first it looks like I would have to divide both sides by 3. So I got X over 3. And then if I want to keep trying to solve it, then I would minus 6 on both sides. So then I'd have X over 3 minus 6 equals Y cubed. And, cubed. And then I would cube root both sides. And you'll notice I got the same thing as I got over here. So P inverse of X is the cube root, and I see a lot of you guys not making your root big enough. So like all this stuff in here has to be underneath the root. Like some of you guys are making your root so maybe it just goes over the X but not over the 3 or whatever. So you can leave it like this, or you could have written it as X, let's see, you could have like, what would this be over 3? X minus 18 over 3? I would just leave it like this. Okay, this one I'm going to do it a little bit faster. I'm going to just do it the way that I did over here. I'm just going to swap the X and the Y. So I'm going to write it as X equals 3Y cubed plus 6. And then I'm just going to solve for the Y. So I'm just going to minus 6 on both sides. So I get X minus 6 equals 3Y cubed, and then I have to divide by 3. And that gives me y cubed is this value. So y is going to be the cube root of x minus 6 over 3. And then I can rewrite that as x over 3 minus 2 if I want to, or I can leave it alone, but I am asked to write it in this special function notation, so I have to go. Oh, and this was wasn't I cube rooting? Yeah, sorry, cube rooting. This one's weird. You can't do this one this way because you can't tell what happened to x first. You don't know if the x got, if one got added to x first, or don't really know the order. So you kind of have to, you're kind of forced to do this one this other way anyway. So this one would be y equals. So that would be x equals. And then I want to try to get the y's by themselves. So I think I would do cross products. So I'd probably say and then I have to do a lot of weird math here. So I'm going to trying to get the y by itself. And then let's see, I'm going to move this one over to the other side and move this to the other side. And then I'm going to factor out, I'm running out of room, I'm going to factor out my y. And then I'm going to get the y by itself by dividing both sides by like that. And then so I have y equals, this is a weird way to write it, negative x minus 1 over 1 minus x. So it might be a little nicer to multiply the top and bottom by negative 1. And that's just going to change all my signs. So that's going to make it be. And then I can rewrite it as and it's really weird, but this one and this one, they're the same, that they're inverses of each other. So h inverse of x, I know, weird, weird, weird. And then this last one, I'm going to do it the way I did all the other ones. I'm going to write it as y equals 2 over 3 minus x, and then I'm going to let the x and y switch places. And I'm going to try to solve it for y, so I'll use cross products. Running out of room. So it's a lot of algebra. When you take integrated 3, it's kind of like you're taking your Algebra 2 class. I'm trying to get the y by itself, aren't I? So I'm going to subtract 3x on both sides. And then I'm going to divide both sides by negative x. And I'm going to have and then if I want to change some signs, I can. I could say, I could write it as, it's a couple different things I can do. Let's look in your book and see. They wrote it as negative 2 over x plus 3. So we can do it that way. So this part gives me negative 2 over x, and then this part, the x's will cancel out, and it'll be plus because it's negative divided by negative is positive. And that's what y is. And then we've got j inverse of x. I think you could have also done this one the way we did up here.